Thank you for joining us for our series on generative AI. I'm Kevin Boyd, the CIO at the University of Chicago, and I'm very pleased to have with me today Sanjay Krishnan, a faculty member at the University of Chicago.
Thank you for having me.
So Sanjay, we're going to have a discussion today about building generative AI models, and this is probably a slightly more advanced module in our series, but of course we're going to try and make it accessible for a broad audience.
Absolutely.
Now, when we think about generative AI, can you tell me about some of the tools and platforms that, from your perspective, are really essential for developing generative AI today?
Absolutely. And I think that the best way to think about the tools and the platforms is think about who uses them first. So I think that when we think about generative AI, there are 3-4 major types of users in this world. There are first the major tech companies, and they are interested in training what we call foundation models. So these are like the ChatGPTs, the Geminis, the Bards of the world. These are models that take in the internet of data, literally the internet, a very vast corpus of data, petabytes of data. They use a lot of massive large-scale computing to train these models. And these models are what they sound like. They are foundation models. They give us a basic understanding of human images, human video, human language, right? And they're really a starting point for other AI projects. Now, beyond the foundation model trainers, there's a next set of enterprise users and scientific users who might want to do what they call fine-tune these models. Fine-tune these models means that you have some data that you have on your own, or you have some problem that you would like to solve. Like, I would like to improve my prediction of treatments for asthma, for example, right? So I might have a task that I'm interested in, and I have some data that is specific to my task. I might want to get one of these foundation models to work better on that particular task. These are, the next set of people are fine-tuners. These are people who have data, who have very specific problems, and who want to leverage these foundation models, but those foundation models weren't intended to solve anything like their tasks. Now, the last set of people are people like you and me who often just casually play around with these tools and use it in our day-to-day lives. These are people who work with these models in terms of prompts and their outputs. So we might work with ChatGPT, not caring about exactly how it was trained, not caring about the underlying software and hardware that was required to train it. We're just interested in querying this model and see its outputs. So we have these 3 sets of users, and it's really important to understand that the tools and platforms are different for these sets of users. Foundation models are in the realm of large-scale tech companies, foundation model training. Fine-tuning is really accessible to everyone, even you and me. With a little bit of work, we can pull up cloud-based tools that can help us fine-tune these models if we had a data set in front of us. And then we're going to see a large portion of users who simply interact with these models, querying and prompting it for different types of outputs.
So let's talk about the group in the middle.
Yep.
So imagine that I'm a student at the university and I want to start experimenting. With the wide variety of tools that are out there, how should someone think about deciding which tools or platforms to work with?
So I think that anybody who wants to experiment with AI, the first thing that I always say is that these tools are not intelligent in the way that you and me think of intelligence. They are optimizing some kind of a numerical objective. So they have prompts and they have outputs, and they really try to say, how do I build a model that maps these prompts to these outputs? So you need to be first very clear about what problem you're solving and how to quantitatively measure success. That's kind of a step 0, right? You need to think about, do I have a problem that I can nice and crisply measure what success actually means and what a good output actually means? And I need to be able to programmatically do that. It can't be something qualitative like I hand it off to 3 experts and if 2 out of 3 like it, then it's good, right? It has to be something that a program can measure. Once we get to that point, then there are plenty of tools out there with a 30-minute tutorial using tools like the Google Colab environment, which allows you to access a limited amount of free computation on the Google Cloud computing engine, as well as tools like PyTorch and TensorFlow. It is easy to actually fine-tune open source models to do what you want them to do. But the first step is really to think about, does the problem that I have lend myself to AI? And the first step is, can you quantitatively and programmatically measure what success means at it?
Okay. Well, certainly starting with the problem statement is always a good place to start. So You talked a little bit about how to get started. Are there other initial steps that they should be taking to get going on this?
Absolutely. I think that the first thing that I would encourage anyone to do is to read up on these different models. There is now thousands, and maybe if not thousands, tens of thousands or millions of these different open source models out there. There are repositories for these models where it is easy to download them and test them out on your data. Right? And they all follow, at least in the generative AI world, they all seem to follow a similar pattern. They have prompts, which is usually some kind of an English statement of what you want this model to do, and outputs. So like generate a email that says X, Y, and Z, here is the email. Or generate an image with X, Y, and Z content. Here's the image. Or generate a video that does this. Here's the video. So they all follow the same pattern of prompts and outputs. And large enough of these data sets allows you to train these models. Now, these foundation models are trained on massive data sets. Now, the reason that you might ever want to fine tune these models is that there's no guarantee that foundation models saw prompts and outputs in the way that you intended. You might have a very specific problem. Like you might be a legal services company that is interested in writing contracts. You have a lot of historic contracts and you have descriptions of these historic contracts, right? Now, those contracts were never on the internet. They were never part of the training data that went into these foundation models. And an important part about building these models is that the model sees examples of what you want it to do, right? And the more it extrapolates, the crazier the results get. And I know we've all seen examples of ChatGPT speaking a different language, or like the Mother Teresa fighting cancer, the Dolly pictures where there's literally Mother Teresa fighting something that looks like a cancer bug, right? So I think that we find that when these models haven't seen the examples that you want them to do, they kind of extrapolate. And that extrapolation is often not principled in the way that you'd want it to be.
And as you're saying that, it feels to me like we've started with these very large models that in many cases the corpus is something like all of the content that they can get on the internet. But it seems likely that the models are going to become more and more narrow. To your example, something related to law or a particular area of law or medicine or ecology or things like that, and to refine the models. Does that seem to be the
there are a complex set of trends here, right? Okay. I think that one part of this technology is that these models don't have any causal structure of the world. They don't know the physical world, or they don't know the linguistic world the way that you and me learn the basic rules of grammar and learn composition and figure out how to stitch everything together. They don't know the structure of the essay. They're inferring it from just seeing large examples of data, right? So that is always that training of a foundation model, because we're not putting that structure in there, is always going to be a big to small problem. It's always going to be, we're taking the entire world of the internet, because with enough observations of that entire world of the internet, you learn the structure of typical human photographs, typical human language, or typical human text, and even finer grained than that, typical human emails, typical human essays. So you always need that base understanding of the world, and that's where these foundation models do. And now, just because a foundation model does all of that doesn't mean it's good at any given task. It's a kind of a jack of all trades, a master of none. And that's where fine tuning comes into play, right? It's like you as a user of these models often have a very clean idea of what these models should do, which is a subset of behaviors the model could always ultimately do, right? Mm-hmm. And you want it to do well on those subset of behaviors, not necessarily caring if it can write an essay very well, right?
So with that in mind, can you explain a little bit more of like the basic architecture of a simple generative model?
Absolutely. So most generative models today are based on deep neural networks. So that's a fancy term for their hierarchy of a lot of modeling components. So what they do is they extract different facets of the data that is inputted into them and see them at different scales. What that means is that it looks at how words co-occur, it looks at how sentences co-occur, it looks at how paragraphs co-occur inside a document. Okay, so the basic structure is ultimately a deep neural network that looks at data at different scales. And by many scales, I mean thousands, if not millions of different scales of resolution looking at this data. Now, one piece of the puzzle that allowed these neural networks to specifically work very well on language was something called a transformer architecture. And a transformer architecture has a key component in it called attention. Attention means that not only can it look at data at many scales, it allows the model to selectively choose which pieces of data are more relevant and which pieces of data are less relevant. The combination of these two pieces, deep neural networks and transformer architectures, allowed these models to scale up and learn from very, very large corpuses of data.
Okay, now that's really interesting. And when you talk about the data that's required in order for these models to learn, can you talk a little bit more about the importance of the data and things that we might need to do as computer scientists with the data in order to make the models more effective?
Absolutely. So this is easiest to visualize in the case of language because it's easy to wrap our head. We are all trained to think hard about language, and it's easy to wrap our heads around what generative AI means for language. So again, it goes back to the principle. This model knows nothing about human grammar at its starting point, right? It is simply just a pattern identification mechanism. We give it a lot of data. It starts learning the structure of human grammar. And it starts learning the structure of human grammar by trying to figure out, how do I predict the next word? Okay? And that's really all these models do. As weird as it sounds, all of them really just, when we think about large language models today, they're really looking at all the words that preceded it, what predicts the next word. And that task, that simple predictive task, often requires internalized understanding of the typical rules of grammar, right? And you only kind of infer those patterns when you see a lot of data. Now, if we think about this from one perspective, this is great. We don't have to hard code rules of grammars. We don't have to talk about subjects and objects and prepositions and so on. But on the other hand, we are subject to whatever weird biases and trends are there in the data itself. If that data is not good grammar, this thing might learn to produce outputs that are not good. If that data is biased, right? If it contains the historic biases that the 1990s had or the entire English literature canon had, this is going to cause a problem, right? Those biases are going to be baked into predicting that next word, right? And this is one of those deals with the devil that we make, right? By not coming up with the first principles rules of baking in that structure into the model, we are at the mercy of the data that we have. We live by that data, right? It works when it works well, it works great. But when it doesn't work well, it's going to pull apart all of the different noise and all the different biases and all the different errors that exist in that data set.
So what I hear you saying is the data is really important. We need good data. We need consistent data. Ideally, we need fairly well-structured data. And the model is going to look for patterns in the data and then generate new data, predict patterns based on what it's seen in the other data. We often hear people talk about, okay, well, we need to train the model. But I'm not sure that many of us really understand, well, what does that mean when we talk about training the model? Can you explain that a little more?
Great. So training the model is when we talk about an architecture, right? When we talk about the transformers and the deep neural networks, you can think of it as like scaffolding, right? It is the basic structure of like a building. Okay. And training is kind of filling in the rest of the building, is putting in the bricks over there, right? So we put up the scaffolding when we define a model architecture. We pass it an input data set saying that here are some prompts and here are what you need to generate for those prompts. Then what the training procedure does is it actually runs a numerical algorithm that finds a model that best predicts those outputs from those prompts. And again, to me, it's still incredulous that this works. Sometimes we can have a very short prompt, like write an essay on Abraham Lincoln, produce multiple paragraphs of outputs. But that's what this model is trying to do. And the larger the data set that you have, what it does is it just iterates over every single one of those prompt result pairs in your data set and tries to see, did I do this one right? Did I do this one right? How right was it? And it just goes over and over again, oftentimes for, like, as if some of our sources in the tech industry are trusted, weeks, if not months, turning away, trying to best replicate those results from those prompts. And when that process reaches a termination point, we have the models that we see. And it's kind of amazing that this simple technique of predicting the next words does this at the scale that we want it to. And it's kind of amazing that it works.
That is really fascinating. It is amazing. Like when you articulate it that way, the idea that is enabling all the things that we are seeing with these models today is truly amazing.
Yeah, and it's like it's kind of like I like to always put it to students because like when we talk about this in class and it demystifies ChatGPT, they're like, how does this work? It's kind of the magic is gone. And I say that it's one part a magic trick, right? That the everything you might want to generate has probably been generated somewhere on the internet. So there's one part of memorization, one part realizing that there are many statistical regularities in the way that we speak, we write, the images we take, the videos we generate. The same again, the same way that a literature professor might see motifs across multiple different books, and those motifs are present in new books. The same thing happens with any content that we might want to generate. That there is a world of information on the internet, and oftentimes the things that we want to generate are different parts of that content. Right now, but I think that it's important understanding this technology to understand when it might go wrong as well, right? That it has no real model of the world. It's just a simple prediction device. So if it learns something that learns a pattern that is contrary to current values, it's going to spit that out, right? There's nothing in it that tells it that's a bad pattern to learn.
So I'm going to hope that some of our audience has been listening to this and is now really interested and excited about trying this. Are there some resources that they can use to help them get started?
Absolutely. So if there's a list of resources, this is how I got started. When this first hit the scene, I started playing around with this and I tried to read every single blog post and say, how do I train my own model? Right? A good starting point is the Google Collaboratory. There are free resources out there for you to use a limited amount of Google's cloud compute to train these models. The second piece of software that is really useful is the Hugging Face package. The Hugging Face package gives you access to a large number of open source models. Now, these are obviously not going to be as good as the foundation models that are being trained at Google or OpenAI or Facebook, but it's a good starting point. It's a good starting point to understand capabilities. And the third part is I would encourage everyone who's interested in playing around with this, think about your own tasks. What would it be cool if these models could do it? And sometimes their capabilities might surprise you, right? You might think that there's no way, that's way too hard. And then realize that when I try it out, it actually kind of works, right? And I think that that's a good thought process on your own, is not just picking a task that everybody has done. Think of something clever that you think it would be cool if these models could do and see if it can do that. And if it can't, there's an interesting research question there of why can't it do that?
That's great advice. Okay, so to wrap this up and to build on that, is there any other advice that you would have for beginners who are starting to experiment in this space?
I think just trying out different things, and that's how I have learned about this space. I've learned about the space over the last year, and I think my opinions change every 3 months as the technology changes. It's a very rapidly moving space. It's a space where even the software that you've written 2-3 months ago is obsolete in the next 2 or 3 months. And I think because of that, you have to constantly be learning about what's new. I spend a lot of time every evening reading different blog posts about what people are doing. I'm just curious of how people are leveraging this technology. And sometimes you learn bits and pieces about what it's good at and what it's not good at. And I think that understanding the technology, understanding how it's built, and understanding the practical considerations of actually using this to solve real world products, whether they're in industry, whether they're in science, or whether they're just for fun, are really important to be able to understand what this world is going to look like in 20 years from now.
Great. All right. Well, Professor, thank you so much, Sanjay.
Absolutely.
I really appreciate you joining us for this discussion. And thank you for joining us for this series on generative AI. I'm Kevin Boyd, the CIO at the University of Chicago, and thank you.